Corsi here. In this question we're given a scatter graph. Each of the points, for instance this one here, indicates how many kilometres a car can travel on 1 litre of petrol with the given engine size. So for instance, for this point here, 1.5 litres is the engine size, and the car can travel 14 kilometres and consume 1 litre of petrol. Here's another point on the scatter graph. For a car that has an engine size of 3.5 litres, that car can travel 8 kilometres on 1 litre of petrol. It consumes more petrol, bigger the engine. And that's shown in the scatter graph. And we've drawn a line which is called the line of best fit between these points. Now we're asked to find the equation of that line and to find it in its simplest terms. So let's recall what we know about finding the equation of a straight line. And normally we have an x and y axis. We'll have a straight line. Two ways of going about this. We either say the equation is y equals mx plus c, where recall that m is the gradient of the line and c is the point where the line crosses the y-axis. There's another way of finding the equation of this line. We use the equation y minus b equals m times x minus a. And in this case, again, gradient is given by m, but this time AB is a point on the line. And this might be quite a good one because we do know, well, certainly at least a couple of points there that are on the line. So in this case, however, we have to watch out that we don't have an x and y axis, we've got an e and an f axis. So these two equations will change. This first one will become f equals me plus c, and the second one will become f minus b equals m e minus a. So y has been replaced by f and x has been replaced by e. So let's attempt to use this form of the equation. So what do we need? We need to know the gradient and we need to know a point on the line. So first of all then, a point on the line, that's the easiest one to give. And let's use this point here. We had 1.5 and 14. So that's the coordinates of a point on the line. So next we have to find the gradient of the line. And that's not so straightforward. We do have the coordinates of 2 points on that line, and there is a result that says if we have, for instance, a point x1, y1 on the line and a point x2, y2 on the line, then the gradient of that line will be the y difference, y2 minus y1, over the x difference of the y coordinates divided by the difference of the x coordinates. So let's recall in this case we have the point 1.514 and we have the point 3.58. That was the other point we picked as being on the line, 3.58. So the gradient of the line will be y difference 8 minus 14 over x difference 3.5 minus 1.5. Now 8 minus 14 is negative 6. 3.5 minus 1.5 is 2. And 2 into 6 goes 3, so that's negative 3 for the gradient. So we've found a point on the line and we now know its gradient, so the equation of the line is, and we'll hark back to this version, which is the y minus b equals mx minus a. with y replaced by f and x replaced by e, where we know m, the gradient, and we know AB, we're using the point 1.5, 14. So that's basically the A and the B, and that's the M. So it's f minus b, that's the 14, equals gradient minus 3, e minus a is 1.5. So we have to simplify this. F minus 14, let's multiply out the brackets first. We've got negative 3 times the e, and then negative 3 times negative 1.5 will be positive. 3 lots of 1.5 is 4.5. And this isn't quite finished yet for simplification. Let's add 14 to both sides. We get f equals negative 3e, and then negative 14. Well, we're adding 14 to get rid of this, so adding 14 to 4.5 is 18.5. So that this line of best fit has equation f equals negative 3e plus 18.5. So let's now have a look at part B of this question. So here we have Imar and his car with engine size 1.1 litre. And we're asked to use their equation from part A that we've found to estimate for 1 litre of petrol how far in kilometres he would go, how many kilometres per litre you would expect to get. So we have to use the equation that we've found, F equals negative 3e plus 18.5. Now the engine size 1.1, we know the value of E, it's 1.1. So F, petrol consumption, will be negative 3 times 1.1 plus 18.5. So 3 lots of 1.1 is 3.3, so we have to take away 3.3 from 18.5. So that'll be 15.2. So how many kilometres per litre he should expect to get? So he'll get 15.2 kilometres per litre. I'd expect to get that. And that's using the equation of the line of best fit. Now, it might be wise at this stage just to double check that that answer makes sense when we look at this diagram. 1.1 for the engine size. We travel up to the graph and then travel along to the F scale. Does it look reasonable that that's 15.2? Well, yes, it looks more or less halfway between the 14 and the 16. So there's a double check that that does make a sensible looking answer when you compare it with the graph. That's Mr. Corsi signing out. Hope you enjoyed the video.